Hello students, you should be clear with all the theory that we have discussed in this chapter, some basic concepts of chemistry. So we saw like 5 different laws, law of multiple proportion, definite proportion and things of that sort. So you should be clear with all those laws. Same way we did see mole concept, right? So you should be clear with the idea of moles and all those stuff. So it's like 6.023 into 10 power 23 entities will be there in one mole. So that's the understanding that you need to know. Then we did see molar mass, molecular mass, formula mass and all those stuff, right? So you should be clear with that those particular concept. Finally, we saw like different chemistry terms, right? So it was like molarity, percentage, mass by volume percentage and things of those sort, right? So you should be clear with all the theory stuff that we have discussed. So the PYQ part will consist of like 3 sessions. So in the first session, which means in this session, we will do around like 13 sums, okay? Same way in the upcoming sessions, we will do like 10, 13 sums. Together, you have like 35 questions. So all those 35 questions will be dealt in 3 sessions, fine? Let's jump into the first question. So here you have got equal masses. First question is like equal masses of H2, O2 and methane have been taken in a container of volume V. Got it? So this is a question based on the logic of mole. Majority of the question that we will see will be from the logic of mole concept in this session. Got it? So here I've got H2, O2 and then the methane. We have taken like equal masses. Got it? So the mass is same, which means obviously you will not have same number of atoms or molecules into it, right? Because these stuff has different molar mass into it. So it should be clear that all these different chemical compound isn't having same number of moles of entities in that container. Okay, so here I've got have been taken in a container of volume V at a temperature of 27 degrees Celsius in identical condition. Fine. Then what they're asking us to find is the ratio of the volumes of gases H2 is to O2 is to methane would be. So what I'm supposed to find is what volume of hydrogen is getting occupied in that container. Same thing, I'll have to find it for oxygen and then the methane. Fine. So based on the number of availability of moles, I know the volume will be occupied, right? So it doesn't depend on the mass of the gas, it actually depends on the number of atoms to get the volume of gas. I have already told you clearly in the theory session, whatever the size, whatever the mass of the atom could be, but still if it is in the gaseous state, it is like freely arranged. Therefore, 1 mole of gas will occupy 22.7 liters of volume, right? So that should be the understanding that we need to know. So here they have given us clearly that it is occupying same masses. H2, if H2 was like 30 grams, then oxygen should also be 30 grams. Methane should also be 30 grams. It is not necessary that all the 30 grams contains same number of molecules into it, right? So that's the notion behind it. Same way, so from that, I'll be able to get the volume of gas of H2, O2 and then the methane. Fine, so let me do it. It's just a simple one-step process. You'll get the answer straight away. So let me take it this way. So here you've got hydrogen gas. Got it? So hydrogen gas, I know like 2 gram will give me 1 mole. Fine. Same way, then you have got like oxygen O2. So for the O2, it will be like 16 for 1 oxygen, and then here you have got like 2 oxygen into it. Therefore, 16 plus 16 will give you like 32 grams. Right? So generally, this molar mass will be like will be equal to that of the mass number. So to get the mass number, you might have already known from your lower grades, it will be somewhat close to double the atomic number, right? So the atomic number for the oxygen will be like 8, and then if you put like 8 neutrons into it, so you'll get like 16 nucleons. So for per atom you will have like 16 gram, but in this situation it's like a molecule. Therefore if you take like 32 grams of oxygen molecule, in that situation you will have 1 mole of oxygen into it. Got it? You should be clear with the logic that I'm telling you, because I've already discussed exhaustively in the theory part. So if you are thorough with the theory part, this will be like easy. Then you have got like methane. If you do not know the chemical formula for the methane, do not want to worry about it. Anyway, as we progress in chemistry, you will end up memorizing these kind of simple chemical compound that will automatically flow. So here I'll just give you straight away, which is like CH4. Got it? So CH4 is the methane. So for the carbon, you will have like 12 gram, and then for the hydrogen, you got like 1 gram. So 12 plus 4 into 1, that will give you like 16 grams. So here you have got like 16 grams of methane. Now I'm just done with 1 mole of all those respective molecules. Now let me choose the molecule that has greater molar mass into it. So that will be like oxygen. So for oxygen, let me take 32 gram. In 32 gram of oxygen, I'll have 1 mole. This is obvious. Got it? So I'll fix this one to be my fixed mass, and then I'll compare it with the rest of the molecules that they have given in the question. Next, let me move to the hydrogen. Fine. So I'll have to equate with the same gram that I have taken for the oxygen, because that's the upper limit, kind of upper limit. Okay, so here it's like 2 gram. Then how much should I multiply to get 32? It's like 16. Got it? So to get the 32 gram, that's a pretty simple mathematical logic into it, right? So to get the 32 gram of hydrogen, what should I do is I'll have to multiply it with 16. 16 into 32, 16 into 2 will give you like 32 grams. Then obviously I need to have like 16 moles in 32 gram. Got it? Because they have given in the question clearly that all the masses are taken equal. Fine. So it doesn't matter. It could be like 64. If I've taken like 64 gram, then this will give you like 2 moles in the above hydrogen. You'll get like 32. Proportionally it will increase. But anyway, in this situation, it should be obvious. I'm just getting the ratio out of it, right? So for the case of hydrogen, if I compare it with the oxygen that they've given, I'll have to make it to 32 gram. If I have to make it to 32 gram, then I'll have to multiply 16 into it. Then obviously 16 moles will be there in 32 gram of hydrogen molecule. Got it? So simple mathematical logic into it. Fine. For the hydrogen, you'll get like 16 mole. And then for the CH4, you'll have like 16 into 2. Yeah, right. 16 into 2 will give you 32. Obviously. So to get the 32 gram, you will have 2 moles into it. Fine. Now I'm just supposed to find the ratios into it. So the ratios will be 16 is to 1 is to 2. Fine. I'll not be able to cancel it out because here in itself I have taken it in the minimum pattern. Therefore, obviously 16 is to 1 is to 2 will be my ratio. So here you have got like 16 is to 1 is to 2. The option 3 will be the answer for this question. Got it? Simple, easy sum, straight away sum. Just if you are thorough with the concept of mole, you'll be able to do it straight away, right? Let's move on to the next one. This question is also a simple one. Let me read it. Here you have got what volume of oxygen gas measured at 0 degrees Celsius and 1 atmosphere is needed to burn completely 1 liter of propane gas. Got it? So I've taken propane gas and then I'll have to burn the propane gas completely, and I've taken like 1 liter of propane gas. So this is in gaseous state. Fine. Then obviously in 1 liter it will occupy same number of molecules or moles into it, right? Measured under the same condition. Fine. So here I'll have to match it with the number of moles. That's what I'm supposed to do it over here. So 1 mole of propane gas will occupy 22.4 liter. Here in the situation, they have given you like 1 liter, which means 1 by 22.4 of moles of C3H8 is there in that container. I'll have to burn it completely in the presence of oxygen. If it is a combustion, then the byproducts will be the oxidized form for this molecule, which is nothing but the carbon dioxide for the carbon, and same way for the hydrogen, that will be H2O. So generally when they're asking us to find the combustion, the byproduct will obviously be the oxidized form of particular compound, which could be like carbon dioxide, sulfur dioxide, whatever it is. But when you take hydrocarbons, obviously after you burn, you will end up getting carbon dioxide and then the water. Okay, so these two stuff will be the byproduct. Let me write the equation for it. Just straight away you'll get the answer. Got it? So here you will have C3H8 and I'm going to burn it in the presence of oxygen. Yeah, obviously. So when it burns, it will get into the oxidized state of this C3H8 and it will break. So you will have like carbon dioxide that will be released. Same way, you will have like H2O. That too will be in the vapor state. Got it? So these stuff will be the byproduct, and by the way, heat will be released, right? So this is an exothermic process. Anyway, now let me balance this equation. Once I balance this equation, I'll end up getting the answer. Got it? So here it was like C3. You have got like 3 carbon atom. Fine. So obviously if I have to balance the stoichiometry, I need to have like 3 carbon into it. So 3 CO2 will be there. And then when you look at the hydrogen, so you have got like 8 hydrogen, which means here also I'll have to have like 8 hydrogen into it. So the stoichiometry will be like 4, 4, 2, that gave me like 8. Only stuff that is left to balance is the oxygen. So if you look at the oxygen, you have got like 3 into 2, that will give you like 6 over here. Same way you have got like 4. So 6 plus 4 will give you like 10 oxygen into it, right? So to get the 10 oxygen, here I have taken like O2 molecule, which means I'll have to put 5 as a stoichiometry so that the equation gets balanced. Got it? So you should be clear with this balancing stuff and all those things. These are like easy one. Here I need like 5 moles of oxygen. Fine. So if it was like 1 mole of C3H8, then I need like 5 moles of oxygen to completely combust this C3H8. So obviously that is when I'll end up getting 3 CO2 and then the 4 H2O. Here in this situation, it was not like moles, it was in liters. Got it? If I need, if they have given you like 22.4 liters of C3H8, then I would have needed 5 into 22.4 liters of O2. But in the situation, they have given it easy, simplistic way. Here they have given us like 1 liter of C3H8. Then how much amount of oxygen is obviously needed? It will be like 5 into 1. Therefore, I need like 5 liters of oxygen to completely combust this C3H8. Got it? It is a pretty easy, obvious one. The answer over here is like 1. 5 liter, which is option 1. Got it? You shouldn't have any doubt on this question. Let's move on to the next one. Next question is based on average atomic mass. Let me read it. An element X has the following isotopic composition. Got it? So they have given you the isotopic composition. Do not want to worry about the element. It is just X. Got it? So here 90% of that element has atomic mass 200. Same way 8% has like 199. 2% has like 202. What they're asking is to find is the weighted average atomic mass of the naturally occurring element X is closest to. What I need to find is what will be the average atomic mass. That's what I need to find it over here. So if I have to get that one, just do the average, you'll get the answer. So the average will be something like this. We have already discussed this one in the theory. That should be clear. So it's like 90%. If I convert it to unity, you'll have like 0.9. 90 divided by 100 will give you 0.9. Okay. And then yeah, you have got like 200 atomic mass for that 90%, right? So that will be 200. So that's the first step. That's the first isotope. Then you will have 8%. 8% will be 0.08 and then 199. And the next one will be 2%. That will be like 0.02. That will give you 202. Yeah. Here it should be obvious. If I do the math, you'll end up getting the answer, right? So just do the math, you'll get the answer. Anyway, let me approximate it. If I just approximate it, I'll be able to match the answer over here. It was like 200, that was 90%, fine. And then some 8% of the element was less than this 200, got it? And same way 2% was like greater than this 200 by an offset of 2, which means 202, got it? So here it was like 199, that was like 8%. Same way 202 was 2%. If I do compare this one, it should be pretty obvious. If I do the math for this one, it will come somewhere around like 199.8, something like that. Fine. If I do take the average of this one, obviously if you look at the option, it is clear they haven't given anything related to decimals. Got it? So if I'll have to approximate this one. If I do approximate this one, I'll end up getting the 200 because majority was like 90% and some part 8% was less than that one. Same way some was greater. So just by looking at this one, it should be clear 199 is not possible. That's not a dominating number. Same way 202 is not possible. 201 is also not possible because I know it will be less than 200. Therefore, 200 will be the best match over here. The answer is like 4, option 4. Got it? I have just done the guesswork. Anyway, you should be clear with the sum. You shouldn't have any doubt with the sum. Let's move on to the next one. Next sum is also a simple one based on the concept of mole. Which one of the following has maximum number of atoms into it, right? They are asking us to find the atoms. Let me look into the option. Here they have given you like different element, silver, and then magnesium, oxygen, O2 molecule, and then lithium. Fine. What I need to get over here is which has the maximum number of atoms into it. So to get the maximum number of atoms, obviously something that has the lowest atomic mass will have the maximum number of atoms, right? So these two are oppositely related, isn't it? Which has less mass into it needs to have more number of atoms into it. That is when it will give you like 1 gram. That's the notion and idea, isn't it? Hydrogen will have more atoms to get 2 grams to get it to 32 grams. Well, if you take like oxygen, that will have like very less atoms into it, right? So that's the idea and notion that we have already discussed. Fine. You should be clear with this one. So obviously, from the option which has the lowest atomic mass will have the maximum number of atoms into it, right? So here they haven't confused with like molecules and things of that sort. We will see those kind of question in upcoming questions, right? As if now it should be clear something that has the lowest atomic mass will have the more number of atoms into it. Therefore, option 4 will be the answer, right? Simple, straight away, easy question. You shouldn't have any doubt in this sum. Let's move to the next one. Next question is also based on the concept of mole. They have given you in which case is number of molecules of water maximum. What I need to find is, so in the given option, which has the maximum number of molecules of water into it. That's what I need to get it, right? So they have given you clearly the molecule, right? So it should be obvious. Let me do it. The first one, you have got like 18 milliliters of water, right? So this is not the water vapor. Only if it is in the gaseous state, I'll be able to match it with the 22.4. Okay, here they have given you clearly it is like water, which means it is in the liquid state. Then obviously I'll have to get how much gram will be there in 18 milliliters of water. If I only get that one, I'll be able to get the moles or molecules of water molecule into it, right? But if you look at the option 3, it is in the water vapor state, then I'll be able to match it straight away with the 22.4, which I already know. So 22.4 liter of water vapor will have 1 mole of water molecules into it, right? First, let me do for the option 1, then rest all other options will be easy. So here, 1 liter of water will be equal to 1 kg, right? You should be at standard temperature and pressure. 1 liter will be equal to 1 kg. I'll have to match it with the grams. Therefore, 1 liter will be equal to 1000 grams. Okay. What I need to get is actually 18 milliliters, right? So instead of 1 liter, let me substitute something like this, 1000 ml. Okay. So 1000 ml will have 18,000 grams of water molecule, I mean 1000 gram of water into it. Same way, what I need to find over here is for the 18 milliliter, right? So for the 18 milliliter, you will have 18 milliliter. How much will be that? That's going to be like x. Got it? If I do cancel this stuff, that's a straight away one, right? So 0 will get cancelled out. Therefore, x will be something like this. X will be equal to 18 gram. Fine. So in 18 milliliters of water, you will have 18 grams of water into it, right? So that will be directly matched in the situation. Got it? I've got like 18 grams of water in 18 ml of water. If it was like 18 gram, what was the molar mass of water? Oxygen was like 1. Therefore, that will be 16. 16 plus 2 will give you 18 gram. Then obviously in 18 ml of water, you will have 18 gram of water, which will give you 1 mole. Fine. Therefore, in 18 ml of water, I have got 1 mole of H2O water molecules. Fine. If they have told you like atoms, then in this situation, one molecule will have like 3 atoms into it, right? One oxygen and then 2 hydrogen will be there. If they have given you like atoms of water, then in that situation I'll end up getting 3 moles of atom, because in one molecule I have got like 3 atom. Together I have got like 1 mole of H2O molecule. Therefore, if I have to convert it to atom, I'll have to multiply it with 3 to get the number of count of atoms, right? But in this situation, they have given us straight away. Therefore, 18 ml of water will have 1 mole of water molecules into it, right? You should be clear with that idea. Then they have given you like 0.18 grams. So that's a straight away one. Yeah. Anyway, I'll just do it. Here you have got like 0.18 gram. That's what they're asking us to find. So that will be like X. What I know is 18 gram. That will be equal to 1 mole, isn't it? If I do the solving, what will I get? 18, 0.18 will give you 10 power minus 2, isn't it? Therefore, here X 0.18 gram will have 10 power minus 2 moles. Okay, so here you will have 10 power minus 2 moles. Fine. That is obviously less when compared to the option 1. Then you have got like 0.00224 liters of water vapors at 1 atm and 273 Kelvin. This is a kind of STP, right? Okay. Anyway, you will have you will have 22.4 liters. That will be equal to 1 mole. What they've given over here is 0.00224, right? That should be equal to X. So I'll have to get the X over here. If I do cancel this stuff, I'll end up getting how many decimal places I'll have to move is actually the 4 decimal places. Therefore, it will be multiplied by 10 power minus 4. Therefore, X will be equal to 10 power minus 4 mole. Okay, so that will be the X. For this option 3, you will have 10 power minus 4 mole. Got it? This should be clear. Same way here, it is like they have given you straight away, which is 10 power minus 3 mole of water. When you compare this one, it is pretty obvious. 18 ml of water will have more moles of molecules into it. That is like 1. Rest all other option is less than 1. It's like in decimal places. Got it? Therefore, option 1 is my answer. For fifth question, it is like option 1, right? It should be clear. You shouldn't have any doubt in this question. Straightforward, easy one only. Let's move on to the next one. Next question is a little bit different. Here they have given us, suppose the element X and Y combine to form two compounds XY2 and X3Y2. Okay, so X and Y combines to give like two different compounds, which is like XY2 and then X3Y2, right? Then they have given us, when 0.1 mole of XY2 weighs 10 gram, if I take 0.1 mole of the first compound, I have like 10 grams into it. Same way, if I take 0.05 mole of X3Y2, it weighs 9 grams. What they're asking us to find is the atomic weight of X and Y. I'll have to get the atomic weight of X and Y. That's what I need to get over here, right? In this question, they haven't considered 1 mole. Instead, they have considered 0.1 and then the 0.5 mole. Okay. First, let me consider it for 1 mole. If it was 1 mole, then 1 mole of XY2, then I'll have 1 mole of X, and same way I'll have like 2 moles of Y in the compound XY2, isn't it? But in this question, what they have given us is, I have just taken 0.1 mole of XY2, which means I'll have to multiply 0.1 before it. Okay, so in 0.1 mole of XY2 compound, I'll have 0.1 mole of X element, same way 0.2 mole of Y element, right? So that's the logic, isn't it? If this was the case, then the mass number will be, then the mass weight will be equal to 10 gram, right? 0.1 mole of XY2 will give you 10 gram, isn't it? Therefore, this should equate to 10 gram. Let me do the inner multiplication also. If I do that one, you'll have 0.1 X for the first one, and then same way for the next one, you will have plus 0.2 Y, isn't it? Fine. Let me multiply 10 on both sides of the equation. If I do multiply that one, then you will have something like this. If I multiply 10 on both sides, you will have X, yeah, and then you will have 2Y, which will give you 100. That's the first equation that is needed over here. Same way, then they have given us X3Y2, isn't it? For X3Y2, I'll have to do it the same way. You will have like 3 X moles, and then same way you'll have 2 Y element, 2 moles of Y element. Got it? Here also I have taken 0.05 mole. Therefore, I'll have to multiply 0.05 before it, which will give you 0.053x and something like this, right? Got it? Fine. If I do multiply this one, for the first, you will have 0.15x, 0.15x. Yeah, that's right. Same way, for the next one, you will have 0.1y, 0.1y. That should give you 9 grams. Got it? Yeah, it should give you 9 grams, isn't it? Fine. So even in this situation, I'll multiply it with 10. 10 will be a good approximation, isn't it? Yeah. If I do multiply it with 10, I'll have 1.5. Yes. Let me do it this way. So you will have, if I do multiply it with 10, you will have 1.5x, and then you will have y, which will give you 90, isn't it? This is right. Got it? Yeah. Uh, Let me make this decimal also into a natural number. So let me multiply it with 2. 1.5 times 2 will give you 3. Therefore, the same equation will have 3x plus 2y, that will give you 180. 90 into 2 is like 180. Got it? Now I have got like two equations into it. If I just do the solving, I'll end up getting the answer, isn't it? X plus 2y, that will give me 10. Yeah. So here you'll have x plus 2y, that will give you 100. Got it? I'll just have to solve this one to get the answer. If I do solve this one, yeah, let me make it negative, 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 and then negative. Y will get cancelled out, and then I'll just be left with 2x, which will give you 180 minus 100, that will be 80. X should be 40, right? So if x is 40, then what should be the y? Yeah, let me substitute in any one of the equation, I'll end up getting it. So the first one is like x, so x has to be 40. Only one of the option is there, which is like option 1. Therefore the answer over here is like option 1. If I have to get the y, that too will be simple, right? Just substitute this 40 in any one of the equation, which will give you 40 plus 2y. So that will give you 2y, which will be equal to 100 minus 40, which is nothing but 60. Y divided by 6, I mean y equals 60 divided by 2, that will be 30, right? It is clear. It is like 30 for the y. So the answer here is option 1. This sum is also based on the concept of mole. Only thing is you'll end up getting two different equation. I'll have to solve the equation, just basic mathematics stuff that you might have already done in your lower grades. Just do solve those two equation. You will end up getting one of the variables. To get other variable, just substitute that value in one of the variables. You'll get in one of the equations, you'll get the other variable, right? Got it? You shouldn't have any doubt with this question. Let's move to the next one. Next question is logic based one. Let me read it. If Avogadro number Na is changed from 6.022 into 10 power 23, right? So this is what I have found it, which is like 6.023 into 10 power 23, okay? 2. I'm going to change this Avogadro number to some other number, which is 6.022 into 10 power 20 per mole. This would change. So if I arbitrarily change the 6.022 into 10 power 23 to 10 power 20, then which of the option is going to change? That's what I need to get. The first one is the mass of 1 mole of carbon. Got it? So we know the mass of the carbon atom is same in the nature. It's not going to change. So that's a fixed one. Fine. If I am about to change 1 mole, which is like 6.023 into 10 power 23, that count to some other count, obviously I'll have like one carbon atom to be the same mass. If I do multiply that one with the one carbon mass of one carbon atom, I'll end up getting the different mass number for 1 mole of carbon, isn't it? Because 1 mole of carbon is not equal to 10 power 23, it is equal to some other value that they have given. So here the number of atoms have reduced. Then if I do multiply that one with mass of one carbon atom, I'll end up getting the value which is less than that of the 12 gram. That will not be equal to 12 gram. It will be less than the 12 gram because number of count of atoms that I have taken is actually less. But the mass of the carbon atom is not going to change because that is fixed in the nature, right? Therefore, it should be pretty obvious this would change the mass of 1 mole of carbon because 6.023 into 10 power 23 into mass of 1 carbon atom will give you 12 gram. But in this situation, that's not what they have given. They have changed the number count. Therefore, I'll end up getting value that is less because number count has been decreased. Fine. Therefore, first one, option 1 should be my answer, right? So 1 should obviously be my answer. Let me read rest 3 options, right? So here the next one is the ratio of chemical species to each other in a balanced equation. So that's not going to change because whatever moles that you have taken on the left hand side in the reactant has to match with the product side, right? If it is like 2 mole, then obviously to complete that reaction 2 moles should be needed, right? So the count is not going to change, stoichiometry is not going to change. Then the ratio of elements to each other in a compound, that's not going to change. If I need like 1 mole of X to form, and it is going to combine with 3 moles of Y, then obviously this 1 mole will combine with 3 parts of Y. That's not going to change. So that too will not change because that is how the compound is formed. That's not going to change obviously. The definition of mass in units of grams. Okay, so we have used some other convention to get to grams. So the definition of mass related to grams is not going to change, right? It should be clear, simple, easy, straightforward sum. This is a kind of logic based sum. Got it? You shouldn't have any doubt in this question. Let's move to the next one. This sum is also same as that of the previous sums that we have seen. The number of water molecules is maximum in. So in which option you have got more number of water molecules? Got it? Here for the first one, they have given you like 1.8 gram. I know in 18 grams of water, it is like water. Okay. Therefore, in 18 grams of water, I'll have 1 mole. In the situation, it is like 1.8. Therefore, if you do the ratio logic, you'll get it. So you'll have like 0.1 mole of water into it. Got it? Then in the option 2, 18 gram. Therefore, it will be straightly matched with 1 mole. That should be right. Then here, they have given you straight away, that's like 18 moles. So here for the next one, it is like 18 moles. Obviously, that has to be maximum. Here, they have just given you the count of 18 molecules. That's a very small quantity. Got it? Because in 1 mole of water, you'll have like 10 power 23 molecules. Such a huge quantity. But in the situation, they have just given you like 18 molecules, which is hard to pick. That's a microscopic quantity, right? Therefore, when you look at the option, it is pretty clear 18 moles of water will have maximum molecules of water into it. Therefore, the answer here is option 3, right? Simple sum, straightforward, easy sum. Let's move on to the next one. Next question is, a mixture of gases contains H2 and O2 gases in the ratio of 1 is to 4. Fine, so that's how I've taken it in the ratio of 1 is to 4, which means if it is like 1 part, this oxygen O2 is like 4 parts. In terms of weight, they have given you clearly this is in terms of weight by weight, not by volume, right? In terms of weight, what is the molar ratio of the two gases in the mixture? So in what ratio is this gas present in it? That's what I need to find. Let me take it this way. For the H2, I need 2 grams, right, to get 1 mole. For the oxygen O2, I need like 16 grams to get 1 mole. In the situation, I have taken it in the ratio of 1 is to 4 by weight, which means I have taken, let me consider it this way, for 1 gram of H2, there is like 4 grams of oxygen into it. Fine. So I'll have to match it in terms of equal number with respect to the highest one, right? So here I've made one mistake. Here it should be like 32 gram. For oxygen, it is like 16 gram. Therefore, here it should be 32 gram, isn't it? If I'll have to do it such a comparison, then if it has to be 32 gram of oxygen, if it has to be like 32 gram of oxygen, then how much amount of hydrogen should be there into it? So if I have to get 32 gram, then what should I multiply over here? It should be like 8, isn't it? Yeah, 8 into 4 will give you 32 gram. Therefore, I'll have to multiply 8 in the denominator. Same way, I'll have to multiply 8 in the numerator, isn't it? So it should be like 8 gram divided by 32 gram, right? So in the sum, I'm just going other way around. I'm just going backwards, something of that sort. So 8 gram, with respect to 8 gram of hydrogen, I'll have 32 gram of oxygen. That is when the ratio will be 1 is to 4 by weight ratio, isn't it? Here you have got like 8 gram and then the 32 gram. Now let me take the ratios with respect to the mole. So in 32 gram of oxygen molecule, I'll have 1 mole, isn't it? So that is obvious. In 8 gram of hydrogen, I'll have like 4 moles of H2 into it. Therefore, 4 divided by 1, which is like 4 is to 1. The answer here is option 4, right? You should be clear with this question. You shouldn't have any doubt of the sum. Let's move to the next one. Next question is also simple one. Let me read the question. Which has the maximum number of molecules among the following? So in the given option, which one has the maximum number of molecules? They're asking us to find the molecule, okay? So to get the molecule, maximum number of molecule, first I'll have to get the molecular mass, right? Molecular mass. For the first one, it will be, for the first one, that will be like CO2, isn't it? Carbon will be like 12. And then for the O2, that's going to be 32, isn't it? So 32 plus 12 will give you 44, right? So it is like 44 gram of CO2, therefore that will be equal to 1 mole. That's straight away, easy one. Then for the oxygen O3, ozone, right? For one oxygen, it will be 16. Here you have got like 48. So 16 into 3 is obviously 48. Therefore, even for option 2, O3 ozone, you will have like 1 mole. Okay. By the way, what they're asking is to find is maximum number of molecules, right? Fine. For the first two option, it is like same. Let me check with the third one. 8 gram of H2. That's obvious. 8 gram of H2 will have 4 moles in it. Fine. So that one has to be the answer. By the way, here it is like sulfur SO2. I know for the O2, it will be 32, right? Yeah. For sulfur, the atomic number will be 16, right? You should have memorized the atomic number in the periodic table. Anyway, we will do it in the upcoming chapter. Do not want to worry about that one. Here, the atomic number will be like 16. 16 into 2. Generally, when you do multiply double the times into it, I'll end up getting the mass number, isn't it? That will work out in the situation also, which will be like 16 into 2. That will give you 32. Fine. So, the mass number or the molar mass of the sulfur is also 32. So, together that will give you like 64 gram. Even in this situation, 64 gram of SO2 will give you 1 mole of SO2 into it, right? That too will give you like 1 mole. Therefore, the answer over here is option 3. 8 gram of H2 will have 4 moles of hydrogen, 4 moles of hydrogen molecule. Okay, the answer here is option 3. It should be easy one. You shouldn't have any doubt in this question. Let's move on to the next one. This question is also simple one, little bit tricky. Let me read the question. The number of atoms in 0.1 mole of triatomic gas is. What I need to get is, I'll have to get the number of cones of atoms in 0.1 mole of triatomic gas. Got it? So, they're asking us to find the number of atoms, the count of atoms in triatomic. So, triatomic means I'll have to multiply it with 3, isn't it? So, in 1 mole, I'll have 6.023 into 10 power 23 entities. Here, I haven't taken 1 mole, instead I have taken like 0.1 mole. So this much amount of molecule will be there. What I need to get is the count of atom. It is a triatomic molecule, therefore to get the atoms I'll have to multiply it with 3, isn't it? I've already discussed this logic, therefore if I just multiply it by 3, I'll end up getting the number of atoms in this triatomic molecule. Therefore here it should be like 0.3 into 6, right? So it will be something like this, right? 0.3 into 6.0 some number into 10 power 23. So 0.3 into 6 will give you 1.8. Yeah. So 1.806 into 10 power 23. Just match with the powers, you'll end up getting the answer. So it's like 1.8 into 10 power 23. 1.8 into 10 power 22 is not possible. Therefore, the answer over here is option 2, right? It should be clear. Easy one. Let's move on to the next one. Next question is also simple one. They have given us the maximum number of molecules is present in. Here also I'll have to get the maximum number of molecule. Got it? First, they have given you 15 liters of H2 gas at STB. They have given clearly it is in gaseous state. Therefore, I'll be able to match it with the 22.4 liters. Okay. So obviously, if you do the ratio stuff, you'll get it, isn't it? 22.4 liter will be equal to 1 mole. Here they have given you like 15 liters. Then the number of moles will be equal to 15 divided by 22.4. Okay, so that will give you the answer. So if I do approximate this one, what will I get? So 15 divided by something like this. 15 divided by 20 will give you 3 by 4, isn't it? 15 divided by 20 will give you something like 3 divided by 4. Yeah, if it was like 3 divided by 4, that will be equal to 0.75. Yes, yeah, it should be equal to 0.7. Yeah, it's like 3 quarter, therefore that will be equal to 0.75. But in this case, it is like 22.4. Therefore, obviously, it will be less when compared to 0.75. So you'll get approximately equal to 0.7 moles, right? You should be clear with this approximation that I've done over here. Then for the next one, same way for the next one, here you have got like 5 liters of N2. Therefore, that will give you 5 divided by 22.4, isn't it? Which is again the same way, 1 divided by 4, something of that sort. So you will have like 0.25 if it was 1 divided by 4, but in this case, let me approximate it to 0.2, yeah, 0.2 moles, something like that, right? Then for the 0.5 gram of H2, got it? So here they have given you in terms of gram. Okay, if that was the case, what I need to find is like 0.5 gram will give you X moles. I know to get the 1 mole, I just know it should be like 2 gram, isn't it? So therefore X will be equal to 0.5 divided by 2. That will give you that should give you something like this, right? 5 divided by 20, isn't it? 5 divided by 20, that will again be equal to 0.25, isn't it? Yeah, that will give you 1 divided by 4. Yes, so it should be 0.25. Therefore X over here is 0.25. This is something like this, 0.25. So this one, these two stuff are closely matched. Same way, let me do it for the oxygen O2. Same. Therefore, if I do it for the oxygen, yeah, you will have X, which will be equal to 10 gram divided by, I'm just doing it straight away. So you'll have like 10 gram divided by, oxygen will give you like 32, isn't it? Yes. If I do approximate this one, that will give you 10 divided by 30, which is nothing but 1 by 3. So 1 by 3 will be equal to 0.33 moles. Okay, 0.33 moles. If I compare this one, the maximum number of molecules will fall for 15 liters of H2 gas at STP, right? So that will have the maximum molecules in it. So the answer over here is option 1. Fine. We have already seen more kind of this sum, so you shouldn't have any doubt in this pattern sums, right? Let's move on to the next question, which will be the final question for this session. This one is also same as that of the previous sums that we have seen, which has the maximum molecules. Again, the same sum. For the first one, they have given you like 7 grams of nitrogen. So for the nitrogen, the molar mass will be, it is only nitrogen in, okay? So it will be like 14 grams. So 7 divided by 14, that will give you 0.5 mole, okay? Then for the hydrogen, it is like 2 gram of H2. I know 2 gram will give you 1 mole of molecule. Therefore, here also this, it will be like 1 mole. Then if I do look at the other one, it will be something 16 divided by 9 NO2. For the oxygen, that's going to be 32 plus 14. Yeah, right. So that's going to be a huge number. So 16 divided by a huge number in the denominator will give you answer that will be less than 1. Same way for the oxygen, it will be like 0.5 mole, right? 16 gram. 32 will be for 1 mole. Then for 16 gram, that should obviously be less than 1 mole. So when you look at the option, it is pretty clear. Option 2 should be my answer because they're asking us to find which has the maximum molecules into it, right? So you should look into this one clearly, maximum or minimum, what they're asking us to find, okay? So here it is maximum, therefore the answer is option 2. Fine, right? You should be clear with all the sums that we have seen in this session. In the 13 sums that we have seen, majority of the sum were related to the concept of moles, right? Fine, you shouldn't have any doubt in the sums that we have discussed. So with this, the video gets completed. Bye.